Hello everyone, this video covers section 8.2, hypothesis testing for mu when sigma is unknown. This is technically 95% the same as section 8.1. The only difference is that instead of using z, we're going to use t. But this is 100% the same as 8.1. Remember, this is the claim. Then you have the choice of three alternatives. The first two are one tail, which means you're going to use alpha. This one is two tails, which means you need alpha divided by 2. Notice how this is very similar to step 2 in 8.1. The difference is that z is changed for t and sigma is changed for s, since sigma is unknown, but the process is the same. However, since we're using t instead of z, the rejection region and the p-value is going to use also the t table instead of the z table. So the rejection region is going to be now either t of alpha minus t of alpha or plus or minus t of alpha over 2 if it is two tails. Remember, this will go with this will go with this will go with this. We still haven't done an example that is two tails, but we will soon. Now the p-value, which remember we use the symbol for p-value, and this one for rejection region. If this is the case, then the p-value is going to be the probability that t is greater than t star. If this is the case, it will be the probability that t is less than t star. And if this is the case, just like before, this will be twice times the probability that t is greater than the absolute value of t star. Again, it's the same as section 8.1, except that you're going to change z for t. The conclusion and the summary is always going to be the same for this kind of problems. You had two choices: to reject HO or fail to reject HO. So are the only two conclusions, and then you do the summary. All right, let's do an example, and we'll do the rejection region first, as usual. So here, the mayor of LA claims that the average salary for city employees is $20. So for step 1, the claim is that the average is 20. Actually, he's claiming is more than or equals to 20, because nobody's going to complain if they pay you more than 20. Now, if you have a survey of 25, so that means n is 25, which you notice is less than 30, and the average is 18, since the average is less than what the mayor is claiming, then the alternative is going to be that mu is less than 20. So that's how you'll get step 1. Now, the sample standard deviation happens to be 5, and the value for alpha is 0.05. Remember that this is how you know you have to do this type of questions, because it will say, is there enough evidence? So that implies hypothesis testing. All right, so that's step 1. For step 2, remember we need to find t star, or the test statistic. Remember, this was the square root of n, x bar minus mu divided by s. So in our case, this is equal to the square root of 25 times 18 minus 20 divided by the square root of 5, and this is -2. Okay, now in step 3, remember we need to find the rejection region. remember that the alternative is going to determine what kind of rejection region you're going to need. Since this is pointing to the left side, that means that the rejection region is going to be minus T of alpha with whatever degrees of freedom. Now, in case you forgot, from chapter 7, the degrees of freedom is equals to n minus 1. So in this case, the degrees of freedom is 24. So therefore, the rejection region is going to be minus T of 0.05 with 24 degrees of freedom. We will get following value. Remember, we have 24 degrees of freedom. So 24 is here. And the value for alpha is 0.05, which is this one right here. This is exactly what we did in chapter 7, except that alpha is not divided by 2 unless it's 2 tails. So therefore the value we want is 1.711. So this will be the rejection region, negative 1.711. Just like in chapter A, draw the rejection region. 0 here, negative 1.711 is here. So if you are here, it will be rejected. And if it is here, it will be failed to reject HO, just like before. Now the value for T star, remember T star is equals to negative 2. Well, negative 2 is here. So therefore the conclusion is to reject HO, which means the mu has to be less than 20, which means that there is no evidence to support the mayor's claim that the average salary is $20 an hour, or at least $20 an hour. That's it. Now the p-value is a little bit more tricky, or it looks more tricky at the beginning than the z-table, but you have several ways to find the p-value. You can use the calculator or you can use the table. The table will only give you an approximation, but the approximation, that's all you need. So therefore, I actually think the table may be faster to find the p-value, but I will also show you how to find it using the calculator. Before we do that though, remember that for the p-value method, remember that step 1 and step 2 are the same. I want to change. Now this is the part that is going to be slightly different. Step 3. You actually had to do this for the homework in chapter 7, so you did the homework. You kind of know this, but this is the p-value. The p-value will be the probability that t is less than t star, which means that you need the probability that t is less than negative 2. First, let's do this with the table, and then I'll show you the calculator. The value you're trying to find is negative 2. Since the table doesn't have negative values, by symmetry you can just change this to positive. So the value you're trying to find is the number 2. And remember that you have 24 degrees of freedom. So the number 2 is technically between these two. There you go. Then you look to the top, and on the top, this number is between these two, which is 0.25 and 0.50. So therefore, all you have to do is pick a number between 25 and 50. Any number will do, and that will be your approximation. It is very useful to notice how this is decreasing. So notice how this is 100, 50, 25, 10, and 5. So as you move to the right, the area is getting smaller, which makes sense. So therefore, for the purposes of the class, first you go to the degrees of freedom, find the t star, which in our case, remember t star is equals to 2. Well, this happens to be between this value and this value. So therefore, the p-value is going to be between this value and this one. And literally, you can pick anything between 25 and 50. Just make sure you watch out for the decimal point. So in our case, we can just say that this is approximately equals to point, let's say, 40. That's between 25 and 50. Remember, this is just an approximation, but for the purpose of what we're doing, I just told you this is enough. Because remember, for step 4, what you do, you're going to compare the p-value with alpha. Well, if the p-value is 0.040 and alpha was 0.050, well, clearly this is less. And remember from the rule from last time, remember the rule was this, that if the p-value is less than alpha, that means reject. And if the p-value is greater than alpha, that means fail to reject. And this is on the formula sheet, so you have it there. So since the p-value is less than alpha, that means you need to reject HO, and there's no need to explain this twice. And that's it. Now, if you have a TI 83 or 84, you can also approximate the p-value by doing this, or with a TI 83, 84. Remember, the p-value is still going to be the probability that t is less than -2. So then if you draw a graph, -2 is here. So this is the part you want. It's still the green area, but now you're using t. If you use a calculator, there is a command, just like for the normal distribution. You have to go to second variables, just like you did in chapter 6. But then you're going to pick one that says TCDF. Then it's going to ask you for a lower bound and upper bound. So in this case, remember the lower bound is -1000. So this is the lower bound. This will be the upper bound. So therefore, this will be TCDF. Lower bound is -1000. Upper bound is -2. And then you need to write the degrees of freedom. This is something you didn't have to use before, but now you do. Once you click enter, this will give you the exact value for the calculator, which is 0.02a. And again, if you do the approximation, well, for step 4, if you pick 0.02a, well, this is less than alpha, which was 0.050, and still means reject. So you have the choice to do it this way or this way. It's up to you. All right, let's do another example. In this one, they only give you the data, so you have to find a few things before you start the problem. But you're gonna need just section 3.1 and 3.2 to do this, just like we did in chapter 7. So here it says Pedro claims that cat owners in Long Beach spend on average $8 a week. So therefore, his claim is that the average that people will spend on cat food is $8. Now, the value for n is 10, because you have 10 residents. And you notice here there is no alpha. It's just saying, is there enough evidence to support the claim? Remember that if alpha is not given, alpha by default is 0.05. But we still need x bar, and we still need s. If you use the formulas from section 3.1 and 3.2, you can check that this is equal to 9.2, and you should check that. This is from section 3.1. Section 3.1 shows the mean. And then from section 3.2, I show you how to find the standard deviation. Remember that you can use the calculator to figure this one out and this one out too. Once you use the formula for the standard deviation, this will give you around 3.2. Once you have this, and this, now you can do the problem. Remember that you need to figure out what the alternative is. Well, Pedro claims that you're going to spend at the most $8, but the sample of 10 has an average of 9.2, which is more than what Pedro claims. Right? So after that is the same story. For step 2, you need to figure out T star. Well, T star will be the square root of 10 times 9.2 minus A divided by 3.2. It is around 1.2. For step 3, we need to figure out the rejection region. This time the rejection region is going to be on the right side. Why? Because this is pointing to the right. So therefore the rejection region is going to be T of 0.05, and the degrees of freedom are 9. So we look to the table again. The degrees of freedom this time are 9, and the value for alpha is 0.050, so this is equal to 1.833. So therefore this will be 1.833. Remember the rejection region this time will be on the right side. You have 0 here, 1.833. So this is the rejection region, and this will be the fail to reject HO. And then we do exactly the same thing we did last time. The value for T star, which remember this is called the test statistic. So then we do exactly what we did in all the previous examples. So the value for the T statistic or the test statistic or T star is somewhere here. T star is equal to 1.2, which is not on the rejection region. So therefore the conclusion this time, it will be fail to reject HO, which means that there isn't or there is enough evidence to reject Pedro's claim. This should actually be there is not enough evidence to reject Pedro's claim. And that's it. Okay, what about the p-value? Okay, remember that for the p-value method, so p-value method, step 1 and step 2 are the same. So therefore you don't have to write it again. For step 3, recall that you have two choices. You can use the table or you can use the calculator. So for step 3, we need to figure out this, the probability that T is greater than 1.2. Don't forget that the degrees of freedom are 9. So if we look to the table first, so let's do the table first. You have 9 degrees of freedom. So 9 degrees of freedom, remember, is here. And you are trying to find the number 1.2, which it should be somewhere here. Remember, like 10-15 minutes ago, I told you to notice that this value or these values are decreasing. So therefore, if the number you want is here, just pick something between here and here. We did that before. Or if it is here, something between here and here, and so forth. But what about the number is here? If the number is here, always, and I mean always, use 0.2. That's it. And if the number happens to be here, like if the number was 25 or something, always pick 0.001. So you should make these marks on your table because you can use that on the test. So if the number is here, pick this. If the number is here, pick this all the time, and it will work every single time. If it is here, just pick something between here and here. If it is here, something between here and here, just like we did in the last problem. So in our case, 1.2 is here, so we're gonna go with 0.2. So therefore, this should be around 0.2. That's it. So then for step 4, remember you compare the p-value, which is 0.2, with alpha, which is 0.05. I told you to make sure you have the same number of digits. This one only has 1, while this one has 2. So I just add a 0 there, so that's 0.20. Clearly 20 is bigger than 5, so this means fail to reject HO. That's it. Now if we use the calculator, the p-value is going to be the probability that t is greater than 1.2 again. The lower bound this time is going to be 1.2, and the upper bound is going to be 1,000. So this will be TCDF. Remember that to get to TCDF, you go to second variables and just find TCDF. Make sure it's CDF and not PDF. The lower bound is 1.2. The upper bound is 1,000. And do not forget the degrees of freedom. You need this for the calculator, otherwise it won't work, or it will give you a different answer. And this happens to be 0.133. But again, if you compare the p-value 0.133 and alpha, which was 0.050, clearly this is still bigger and still failed to reject HO. So one last time, you can do this or this when it comes to the T table.